Hello everyone, welcome to We Learn Tutorials. In this video, we are going to learn about laws of chemical combinations. So in laws of chemical combination, you will learn how different atoms and molecules they react or they combine in a chemical reaction. So let's start with the first law. The first law of chemical combination is law of conservation of mass. So it states that mass can neither be created nor it can be destroyed. So let's understand the meaning of this by taking one example. So let's take one chemical reaction. So when carbon reacts with oxygen, we will get carbon dioxide. This is a chemical reaction. In this reaction, carbon and oxygen, these are reactants, and carbon dioxide is the product. So reactant, it is your left hand side of the equation, and product, it's written on right hand side of the equation. So according to this law, since it states that you cannot create mass or you cannot destroy the mass, due to which mass of the reactants will always be equal to mass of product. So we will check this thing also in the example which we have taken. Mass of the reactant, it will always be equal to mass of the product, since we cannot create or destroy the mass. So we'll see and we'll verify. Mass of carbon, it is 12 U. U is unified mass. Earlier it was written as AMU, atomic mass unit, but now it is U, which is unified mass. Mass of one atom of oxygen, it is 16 U, but here we have two atoms of oxygen. So which means 16 into 2, which is 32 U. You can say we can find the total mass of reactant by adding these two. We can add 12 and 32 and we will get 44. So mass of the reactant, it is 44 U. Let's find out the mass of the product. Carbon, its mass 12 U. 2 atoms of oxygen we have. So 2 atoms of oxygen means 2 into 16 U, which will again be equal to 32 U. So if you add these two, you will see again it is equals to 44 U. And here it is verified. You can see in the above chemical reaction, mass of the reactant, which is 44 U, it is equal to mass of the product. We can take one more example also, and in every chemical reaction you can see always mass of the reactant, it will be equal to mass of the product. So let's take an example of water. So water, hydrogen and oxygen, they react or they combine chemically to give us water. So we always have to balance the chemical equation. Balancing means number of atoms of each element on both the sides, it should be same. So that's why I have written 2 here and 2 here. So we have to balance now number of atoms. So these are the reactants and it is product. Number of atoms, you can see number of hydrogen atoms, it is 4, because 2 into 2 it is 4. Number of oxygen atoms, 2 here. Number of atoms of hydrogen, again 4, and number of atoms of oxygen, it is 2. You can see the number of atoms, it is same on both the sides. So you can check the mass also. Mass of 4 atoms of hydrogen, it will be 4 into 1, because mass of 1 atom of hydrogen, it is 1 U. So 4 into 1 will be 4 U. Similarly 2 into 16 U, because mass of 1 atom of oxygen, it is 16 U, and mass of 2 atoms of oxygen, it will be 2 into 16. So which will be equal to 32 U. Now we can add these 4 plus 32, it will be equals to 36U. So total mass of the reactants, it is 36U, and here also we can check 4 into 1 because 4 atoms of hydrogen we have, which means 4 into 1U, mass of 4 atoms of hydrogen 4U, and mass of 2 atoms of oxygen 2 into 16, so which is again equal to 32U. 4 plus 32, it is 36U. Again you can see mass of the reactant, it is equal to mass of the product, and this thing, it was first observed by Antoine Lavoisier. So he was the first person who observed this thing. So in any chemical reaction, this thing was the mass of the reactants, it was always equal to mass of the product. So due to which he stated, Antoine Lavoisier, he stated the law of conservation of mass. So this was all about the law of conservation of mass. Now let's do the second law of chemical combination. The second law of chemical combination, it is law of constant proportions. So this law, it is also known as law of definite proportions, law of definite proportion, and Proust's law. Proust's law, because this law is stated by Joseph Proust, so that's why it is also known as Proust's law. So it states that in a given chemical compound, the component elements will always be in fixed ratio by mass. So this again we'll try to understand with the help of one example. So we'll take example of water. So water is a compound and its component elements are hydrogen and oxygen. So that's what it's mentioned in a chemical compound. So compound, it is water and components are hydrogen and oxygen. So they will always be in fixed ratio by mass. So if you see in water, there are 2 atoms of hydrogen. So let's find out the mass of 2 atoms of hydrogen. Mass of 1 atom of hydrogen, it is 1U. So mass of 2 atoms of hydrogen, it will be 1 into 2. So it will be 2U. Mass of 2 atoms of hydrogen will be 2U. And in water, we have only 1 atom of oxygen, you can see also. So mass of 1 atom of oxygen, it is equals to 16U. Now here it is mentioned fixed ratio by mass. So mass you have found now and you know the mass, so you have to find the ratio of their mass of hydrogen and mass of oxygen. So write down the mass of hydrogen, which is 2, and mass of oxygen, which is 16. So you can find the ratio now. 2 into 1 is 2 and 2 into 8 is 16. So ratio of mass of hydrogen is to mass of oxygen is 1 is to 8. So it means from wherever source you take water, see water, it is available in ponds also, in taps also, lakes, sea, tube wells, so many sources of water are there. But from whichever source you take water, the ratio of the mass of the hydrogen and oxygen, it will always be 1 is to 8, which means 1 part of hydrogen will be there and 8 parts of oxygen will be there in one formula unit of water. Let's understand it in a better way. If you have, now you know the ratio of both the masses, which is 1 is to 8. So if you have 9 grams of water, you have 9 grams of water, it means this 9 gram, it has 1 gram of hydrogen and 8 grams of oxygen. So this is the meaning of this ratio. it will be always in this way, 1:8. So in 9 gram you will have 1 gram of hydrogen and 8 grams of oxygen. Now if you have 18 grams of water, in 18 grams of water you will have 2 grams of hydrogen and 16 grams of oxygen. Because here you can see mass of hydrogen and mass of oxygen. Mass of oxygen, it is 8 times mass of hydrogen. So that's what say, if 2 gram it is the mass of hydrogen, you have to do 8 times. 2 into 8 is 16. So that's why 16 gram oxygen. So we can take other examples also. Always you have to find the ratios of the mass. So carbon dioxide, if we take, we can see carbon dioxide is also a compound in which you can see there we have 1 atom of carbon and 2 atoms of oxygen. So let's find out the mass. So mass of 1 atom of carbon, it is 12U, 12 unified mass, and mass of 2 atoms of oxygen. Mass of 1 atom, it is 16U. So 2 atoms, it will be 2 into 16, which is 32U. Now we can find the ratio of their masses. Carbon is 12 and oxygen is 32. So you can do the cancellation. So 2 into 6 is 12. 2 into 16 is 32. 2 into 3 is 6. 2 into 8 is 16. So you can see the ratio is 3:8. Which means in one formula unit of carbon dioxide, you have 3 parts of carbon and 8 parts of oxygen. So we can take, if you have 11 grams of carbon dioxide, 11 gram of carbon dioxide means 3 gram of carbon is there and 8 grams of oxygen is there. So this is the meaning of the ratio. So now we have understood both the laws, we have done both the laws. Now try to do some related questions. So the first question is, in a chemical reaction, 5.3 gram of sodium carbonate reacted with 6 grams of ethanoic acid. The products were 2.2 grams of carbon dioxide, 0.9 grams of water, 8.2 grams of sodium ethanol. So this we have to show that this chemical reaction is in agreement with law of conservation of mass. So in law of conservation of mass, we have studied that mass, it cannot be created nor it can be destroyed, due to which mass of the reactant, it will be equal to mass of product. You can see here sodium carbonate and ethanoic acid, these are reactants, and sodium ethanol, carbon dioxide and water, these are the products. So their masses are given to us. Let's see the mass. Mass of sodium carbonate, it is 5.3 grams and it reacted with 6 grams of ethanoic acid. So let's find out the total mass of reactants. We can add this 5.3 plus 6 grams, and if you add, you will get 11.3 grams. So mass of the reactants, it is 11.3 grams. Let's check the mass of products now. Products, 2.2 gram of carbon dioxide, 0.9 grams of water and 8.2 grams of sodium ethanol. So again, let's find the total mass of products. We can add all the masses, 8.2 plus 2.2 plus 0.9. So you can add, so on adding again you will get 11.3 grams. So you can see mass of the product, mass of the reactants, which is 11.3, it is equal to mass of the product, which is again 11.3. So which states that the given example or the given condition, it is in agreement with law of conservation of mass. Now let's do the next question. In question second, it's given hydrogen and oxygen combine in the ratio of 1:8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas? So in this question, it's given ratio of the masses of hydrogen and oxygen when they are forming water. So hydrogen it is 1, oxygen it is 8. So as per this ratio, we can see mass of oxygen is 8 times mass of hydrogen. See, mass of hydrogen is 1 and oxygen is 8 times, means 8 into 1 is 8. So now what is given? What mass of oxygen gas would be required to react completely with 3 grams of hydrogen? So if the mass of hydrogen is 3 grams, so mass of hydrogen if it is 3 grams, so what will be the mass of oxygen? Since from this ratio we can see mass of oxygen it is 8 times mass of hydrogen. So if mass of hydrogen is 3 grams, then mass of oxygen it will be 8 into 3. See here it is 8 into 1. So here it will be 8 into 3, which is equal to 24 grams. So from this ratio itself we can conclude that mass of oxygen it is 8 times, and that same result we are using in this question to find the mass of oxygen. So this was all about laws of chemical combination and the related questions. So I will make the next video on Dalton's atomic theory. So if you like this video, do share, do subscribe. Thank you so much for watching the video.